So today, 3-5, we're solving 3 variable system equations using the substitution method. Steps to solve with substitution. So the steps are, 1, you make sure equations are written in standard form and number equations. Step 2, choose the equation that would be the easiest to get a variable alone. Usually it's the variable, the variable with coefficient 1, and then get the variable alone. Step 3, substitute the expression into the other 2 equations and simplify to standard form. Step 4, write the 2 new equations as a system and solve using either elimination or substitution for the 2 variables. You can see that I don't know what happened to my A. Substitute the 2 variables into the equation in step 2 and solve for the last variable, and then check your solution set by substituting values into all 3 equations. So that's what we're going to do. I'll give you guys a moment to copy it down. So our first example that we're going to do with substitution is here. So we have 2x plus 3y minus 2z, and -1 equals -1. We have x plus 5y equals 9, and we have 4z minus 5x equals 4. Okay. So step 1 is making sure it's in standard form, and we're going to number. So equation 1, equation 2, equation 3. Okay. And so from looking at this, we can see which equation would be better for us to get by itself for step 2, and that equation would be equation 2. And the reason why is because we look for the one that has a coefficient of 1, and 1x is right there. So we're going to move forward and try to get x by itself in step 2. Okay. Step 1, now we're on to step 2, and we're going to use equation 2. With x plus 5y equals 9. And we're going to get that equation, we're going to solve for x, so we're going to get x by itself. So in order to get x by itself, we're going to have to subtract 5y from both sides. So now we know that our x equals 9 minus 5y. Keeping that in mind, x equals 9 minus 5y. So our next step is, once you have gotten a variable by itself, you're going to substitute that value into the other 2 equations. So I'm substituting into equation 1 and equation 3, which are the ones I didn't use. I'm going to substitute in the value of x. So in the first one, that's going to become 2 times 9 minus 5y plus 3y minus 2z equals -1. And I'm going to clean this up. So I'm going to distribute, gives me 18 minus 10y plus 3y minus 2z equals -1. Combine like terms. And that gives me -7y minus 2z equals -19. Okay, and I'm going to do it again for equation 3. So I'm going to substitute in x into equation 3. Do it into equation 3. That gives me 4z minus 5 times 9 minus 5y equals 4. So I get 4z minus, and we're distributing, 45 plus 25y equals 4. I'm going to combine my like terms, which is I'm going to be adding 45 to the other side. I'm just going to rewrite this so that it's still y then z in alphabetical order. So 25y plus 4z equals 49. All right. How do we feel about step 2? Any questions, comments, or concerns? None? Okay, so then after this step, we now are going to formulate. I just had a brain fart on what the thing was called, y'all. Formulate a smaller system and 2 variables. So smaller system and 2 variables is where we're going. Oh man, my pen is doing some weird. I think my pen is losing some juice though. It's been acting kind of funny. And I don't know why. Okay, there we go. Step 3. So now we're going to take 25y plus 4z equals 49, and we have negative 7y minus 2z equals negative 19. Now, at this point, we have the choice to either solve by continued substitution, or we can switch over to elimination. And personally, I would switch over to elimination. It's kind of, elimination, I prefer over substitution for 2 variable, because it's already kind of small and makes it kind of easy. So I'm going to eliminate z. And the way I'm going to do that is by multiplying the second equation by 2. And when I multiply the second equation by 2, my new equation that I'm working with is negative 14y minus 4z equals negative 38. Okay? So what this is going to allow me to do is eliminate my z's. And I'm adding negative 14y and 25y. And that's going to give me 11y equals, and I'm adding 49 and negative 38, and that's going to give me 11. So we know that y equals 1. Okay, so now we know that y is 1. We can take that value and plug it into either of the systems that we got in step 2. So I can, it doesn't matter. I'm going to go with the smaller number over here. So finishing solving for z, we have negative 7 times 1 minus 2z equals negative 19. So we're going to add 7 to both sides, gives us negative 2z equals 8, negative 8. No, negative 12, Sean. I don't know what kind of math I just did there, y'all. Negative 12. So therefore, when I divide by negative 2, z equals positive 6. Okay. Questions about how we got z? None? Okay. Cool. And we'll continue. So I think I've done a horrible job of numbering my steps. So 2. Oh, I did 3. I misnumbered 4. I was like, I feel like I did something wrong, y'all. And then step 5 is to plug in what I have, and to step 2 to find x. So step 5 is we're going to take what we got from step 2, which was x equals 9 minus 5y. We're going to plug in what we know. So x equals 9 minus 5 times 1. So x equals 9 minus 5, x equals 4. So we end up with x equals 4. And so our solution set is 4, 1, 6. That's our point of where the planes would intersect. And so to check it, remember you can do mental checking. So when you're mental checking, I'm plugging in 4 for x. That gives me 8. I plug in, I'm going to write it above, 8. This gives me 3. This gives me 12. And 8 plus 3 is 11. 11 minus 12 is 1. Check. I'm going to do the next one. So we have 4. Then we plug in 1 and we get 5. 4 plus 5 is 9. Check. And then here we have 4 times z, which is 6. So 24 minus 5 times x, which is 4, which is 20. 24 minus 20 is 4. Yay. It all checks out. Okay, and so when you're doing step 6, again, it can be quick and simple. It can be on paper. It can be full on if you need to, but it's just a check to make sure that your answer is correct. Okay, questions so far about substitution? Sorry about the poor numbering. I will do better on the next example. None? Okay, so our next example, we have x minus 2y plus z equals -4, and -4x plus y minus 2z equals 1. And then we have 2x plus 2y minus z equals 10. Okay, so looking at this problem, to solve by substitution, we want to decide which equation would be the easiest to get by itself. And we have a couple options because we have multiple variables with a coefficient of 1. We have 1x, we have 1z, we have -1z. So you have choices here. So I may solve with x and someone else may solve with z. It does not matter. So I'm going to go ahead and go with x because, just used to getting x by itself. But they're all in order. I'm going to number them so that when I'm referencing them, I know what I'm talking about. And now I'm going to begin. So step 2, I'm going to use equation 1 to solve for x. Right? So I have x minus 2y plus z equals -4. To get x by itself, I'm going to have to add 2y and subtract z. I can do it all at once, right? So I'm going to be adding 2y and subtracting z. So that means x equals -4 plus 2y minus z. This is what I'm going to be substituting in. And then when I'm done, step 5, I'll be back to you. Okay. Step 3, I'm going to substitute this value into the other 2 equations. So I'm substituting that into equation 2 and 3. So substituting that in to equation 2 and 3. So I have -4 times -4 plus 2y minus z. There we go. Close parentheses. Plus y minus 2z equals 1. That's one that I'm substituting into. And then the other that I'm substituting into, it's going to be 2 times -4 plus 2y minus z plus 2y minus z equals 10. I think I got everyone in there where they're supposed to be. And now I'm going to clean these up. So I'm going to simplify. I'm going to distribute. And -4 times -4 is 16 minus 8y plus 4z plus y minus 2z equals 1. Combine like terms. So to combine like terms, I'm going to have to subtract the 16 so it can join its friend on the other side. And I have -8y and +y. That makes -7y. I have 4z and -2z. That makes +2z. And it's going to equal 17. I didn't mean to say 17. It's going to equal -15, y'all. Morning. My brain is still waking up. But today I'm being extra careful, making sure I catch all my little craziness. And guys, by all means, if I make a mistake, tell me. I'm going to distribute, distribute, distribute. And it's going to give me -8 plus 4y minus 2z plus 2y minus z equals 10. I'm going to add 8 to the other side so you can join its like term. I'm going to combine 4y and 2y, and that makes 6y. I'm going to combine -2z and 1z, and that makes -3z, which all equals 18. Okay, this one I'm going to show you guys that you can continue to solve this instead of using elimination. You can solve this by using substitution. So I can continue to substitute now that I have these new equations. So for step 4, we're going to solve this system, these two, with substitution. To solve with substitution, I'm going to get z by itself. So it's 6y minus 3z equals 18. I'm going to get z by itself, which means I'm subtracting 6y and dividing by -3. So we know that z equals -6 plus, -6 plus 2y. 18 divided by -3 is -6. -6 divided by -3 is +2y. So I can take this and plug it in here and solve for y, and then z, and then keep going. So I'm going to plug this in to there. So we have -7y plus 2 times -6 plus 2y equals -15. Combine, distribute, and combine like terms. We have -7y minus 12 plus 4y equals -15. I'm going to add 12 to both sides. And I'm going to get -3y equals -3. So we end up with y equals 1. So we now know what y is. And we can take the value of y and plug it in here and find what z is. So we plug in there. And we end up that z equals -6 plus 2 times 1. And that's -6 plus 2, which equals -4. So now we have z. Okay, step 5 is you take your two variables that you got, and we're going to plug them back into step 2. So I'm plugging in for y, and I'm plugging in for z. So x equals -4 plus 2 times 1 minus -4. which equals -4 plus 2 plus 4, which equals -2 plus 4, which equals 2, equals x. So my solution is, where the three planes will meet is at 2, 1, -4. And again, on step 6, when you're checking, it's as simple as you doing it mentally. So 2 minus 2 plus -4. 2 minus 2 is 0. 0 plus -4 is -4. Check. Then I have -8 plus 1 and positive 8. And -8 and +8 are going to cancel each other out, and I'm left with 1. Then I have 4 and 2 and +4, and 4 plus 2 is 8, 8 plus 6, and 6 plus 4 is 10. So that solidifies that my answer is correct. Okay, so I showed you an example where once we got to step 4 for solving the system, we used elimination. And then I showed you an example that when we got to step 4, it was feasible to use substitution again. The reason why it was feasible to do substitution again is because by using substitution, it wasn't going to create any fractions for me, because the values, 2 of the values that I would be moving were multiples of one of them. And so if you're good with fractions, you can use substitution all the time for step 4. But if you're not good with fractions, then you may want to avoid using substitution all the time with 4 and probably stick to elimination. Okay, the last thing we're going to do is a word problem. So we're going to set it up and solve it with substitution, and that will be it. Whew. So we have, you manage a clothing store and budget $6,000 to restock 200 shirts. You can buy t-shirts for $12 each, polo shirts for $24 each, and rugby shirts for $36 each. If you want to have twice as many rugby shirts as polo shirts, how many of each type of shirt would you buy? So going back to our word problems, before we start anything, we have to identify our variables, right? So we got to identify our variables. What are we going to let x equal, y equal, and z equal? So we can let x equal our t-shirts. We can let y equal our polos. And we can let z equal our rugby shirts. Okay? So that's the beginning, identifying what we're talking about. And then we're going to need to create our system. So creating our system based on these variables and the words in the problem. So the first thing it tells us that you manage a clothing store and budget $600 to restock 200 shirts, right? So in total, you know that x plus y plus z equals 200. You also know that you only have $6,000 to spend, and each shirt has a price. So t-shirts cost $12, $12 a t-shirt. Polo shirts cost $24, and rugby shirts cost $36. And your budget is $6,000. You want to have twice as many rugby shirts as polo shirts. So our rugby shirts, which is Z, is going to equal twice as many as our polos, which is Y. So this is our system. And this system, the reason why you solve it with substitution is because it's already set up to do that. So following the steps, so step 1, they're already in standard form. Here's equation 1, equation 2, equation 3. Step 1 is done. Step 2 is to decide which equation you're going to use to get a variable by itself. Well, the variable is already by itself. Z equals 2y. So I know which equation I'm going to use to substitute in. Step 3 is to substitute that equation into the other 2 equations. So I'm going to substitute z equals 2y into the remaining two equations. So that's going to give me x plus y plus 2y equals 200. Combine like terms, and that gives me x plus 3y equals 200. Okay, and then I'm going to substitute into the other equation. So I have 12x plus 24y plus 36 times 2y equals 6,000. So we have 12x plus 24y plus 72y equals 6,000. 12x plus 96y equals 6,000. Did I do everything right? I think I did. I hope I did. I don't think I dropped anything. I have a very bad habit of dropping things. I think I did good. Do y'all see anything I missed? Okay. So now we have our two equations. Okay, and again, now that we're at this step, for step 4, it kind of leads itself to doing substitution again, because I have another variable that I can easily get by itself that has a coefficient of 1. So I'm going to solve for x. X equals 200 minus 3y. And I'm going to substitute x into here and solve for y. So I have 12 times 200 minus 3y plus 96y equals 6,000. And that gives me 2,400 minus 36y plus 96y. I could try to squeeze it in there, but I didn't leave any room, y'all. Equals 6,000. So we have 2,400 plus 60y equals 6,000. Subtract 2,400. And we get 60y equals, is that 3,600? Yeah. And divide by 60. So we know y equals 60. We know y equals 60. And now that I know what y is, I can take y and substitute it in here to solve for x. So I'm going to solve for x through substitution again. So I'm going to substitute in, and we have x equals 200 minus 3 times 60. So x equals 200 minus 180. So x equals 20. And I'm also going to take y. I don't want to draw an arrow all over here, but substitute in the beginning to solve for z. So z equals 2 times 60. So z equals 120. So then we have our total of everything. So in words, what do I need? I need room to write it. So X represents t-shirts. So I bought 20 t-shirts. I'm going to buy 60 polo shirts. And my moneymaker, are my rugby shirts. So I'm going to buy 120 rugby shirts. And that's my answer. Okay, so let's recap the steps that we went through. So step 1, step 0 was creating the system. So we created our system from the word problem. And then step 1, we made sure that everything was in order. Our equations were numbered to help us stay organized if we needed to reference them. Step 2, we got a variable by itself. Sorry, I didn't remember. We got a variable by itself. It was already set up in our system by itself, so it made it super easy. Step 3, I'm going to call this 3A and call this 3B. We substitute that variable into our other 2 equations. So we substitute that variable into our other 2 equations. Step 4, we use substitution again to solve for our missing 2 variables. So we solved for x and substituted that into our 12x plus 96y equals 6,000. And when we substitute that in, we solve for y. And then once we got the value of y, we substitute it in to solve for x. So it's a circle of substitution. So we substitute it, and then we solve, and then we substitute it, and bam. And then our 5th step was to take our values that we got, plug back into step 2, and got our final answer. And then step 6 would be to check it, in which you can. 20 plus 60 plus 120 is 200. 2 times 60 is 120. And then that one you can also check. But since the first 2 checked out, I'm going to be like, oh, I'm kind of in a good shape. Okay. And then that concludes this. Personally, this looks a lot better when you're working it vertically. But when I'm working with horizontal space, it kind of gets a little all over the place. But when you're working on a vertical piece of paper, it looks a lot neater and it's a little bit easier to follow. I hope the arrows help. So your substitution practice, it's 2 problems. You have a very similar word problem, and then you have just a traditional system for you to solve using substitution. And that is it.